Okay, so we start with the system of equations and two unknowns. Now, I'm just gonna solve this to refresh your memory. Then I'm gonna solve it again in a very structured way. It's gonna lead us to what's called augmented matrices and solution by elimination. And we're gonna use elimination to solve this. We could use elimination or substitution. If you recall, one thing we can do is we could solve this first equation for y. And we get y equals what, 4x plus 1 over all over 3, and plug that in down here and get an equation that just has x in it. So we've eliminated y as a variable, and we've solved that for x. Then we can take that solution, plug it in for x, and solve for y. That should be familiar if you've done the homework on substitution. But we're going to emphasize elimination, which is what I'm going to use here. Okay. Okay, so what I do is, actually, I am going to use a circle 1 to refer to this equation, a circle 2 to refer to this equation. Now I'm going to multiply the first equation by 3, meaning I multiply both sides by 3. And I'm just going to write down, well, I'm going to do -4 times the second equation. Well, 3 times the first equation, to multiply 3 times this side, well, by the distributive law, that's going to be 3 times 4x minus 3 times 3y. So I'm just going to multiply every coefficient by 3. I get 12x minus 9y. And I've got to remember to multiply this side by 3, otherwise I've unbalanced my equation. I don't want to do that. I walk around unbalanced too often. Okay, I don't want my equations to go around unbalanced. All right. And then -4 times the second equation is going to give me -12x minus 16y equals 28. And that's going to work out. Okay. Then I'm going to do equation 1 plus equation 2. Now by equation 1 here, I mean the equation 1 from the last step, not the original equation 1. Okay, so if I add these, -12x and -12x gives me 0. And I have -25y. And I have 25. -9y and 16y is 25y, -3 and 28 is 25. There it is. So now the equation, I can just write as -25y equals 25 because the 0 makes no difference. And now I subtract, or I divide both sides by -25. And I get y equals -1. I take that solution and plug it back into either of the two equations. I'll just choose the first one, but I could have chosen the second one. And if I replace y by -1, I get 4x minus 3 times -1 equals -1. So I'll kind of circle this -1 to indicate that the -1 goes from here, replaces y, and there it is. Clear? So this gives me 4x plus 3 equals -1. And so that gives me 4x plus 3 minus 3 equals -1 minus 3. Okay. doing something in my head and it wasn't coming out right, but just because it was wrong. Okay, so we get 4x equals -4. So 4x over 4 equals -4 over 4, and we get x equals -1. Okay. So if x is -1 and y is -1, both of these equations should be true. Well, if I plug -1 in for x, here I get -4. 4 times -1 is -4. -3 times -1 is +3. -4 plus 3 is -1. If you write it out, you're going to get -1 on this side, -1 on this side. If you replace x and y each by -1 here, well, you're going to get -3 and -3, which does add up to -7. And if you have to write it out, that's fine. Okay, so that's the basic process. Now, we're going to do this just a little differently. In a little more organized fashion. Okay, so same system of equations, but I put them in brackets. And I label the equations 1 and 2. And I don't think of these now as equations, I think of them as rows. Okay. So now first row is, well, the first equation. The second row is the second equation. I can also think columns. The 4x and the 3x are in a column, -3y and the 4y are in a column. The 1 and the 7 are in a column. You got a column here with the x's, column here with the y's, column here with the numbers on the other side of the equal sign. Now what I do, I use the same steps. I do 3 times equation 1 and -4 times equation 2. And we just do it. We get 12x minus 9y equals -3, and -12x minus 16y equals 28. Exactly the same thing I did over there. I just multiply 3 by every number here, multiply 4 by every number here. And I get an equivalent system. This equation has the solutions to this equation are exactly the same as the solutions to this equation. The solutions to this equation are exactly the same as the solutions to this equation. And well, now what do? This is going to be a little bit different because I'm going to write down the first equation, and then I'm going to write down the first equation added to the second equation. Now, there's a reason for doing this, but we're just going to do it. And then when we get in a little while, we'll see why. Okay, so the first equation, and this means the first equation from before, is 12x minus 9y equals -3. I mean, now, when we did it over here, I just added the first equation to the second, right? I didn't write the first equation down again. And then I just threw the 0 away because it didn't make any difference. And I just solved the resulting equation, okay? Well, in this case, if I add 12x to -12x, I get 0x. I'm going to write that 0x down there. Even though in most cases, in isolated equations, you would just eliminate 0x because it would have no effect on the balance of the equation. Okay, so we have 0x, and then the -9y and -16y as before gives us -25y. And the -3 and the 28 gives us 25. Okay? Now, instead of solving the second equation for y as we did previously, and I guess maybe I can pull the board over. So maybe you can see more of what we did before. Yeah, that kind of does it. Okay. Yeah, we're doing the same thing, but we're doing it in a different format. Okay, so what I'm going to do next is I'm going to keep equation 1 there, but I'm going to take equation 2 and divide it by -25. So I've got 12x minus 9y equals -3, and 0x minus what? Well, no, -25y divided by -25. Well, -25 divided by -25 is 1. A lot of times we'll just write down y, but I'm going to write down the 1, just like I'm writing down the 0 here. When I solved over here, I just put the 1 in front of y. I just threw the 0 away because it didn't make any difference. Here, I want to keep the numbers in front of x and y all the way down. All right. Now this will then equal 25 divided by -25, that's -1. So you should verify, if I divide both sides of this equation by -25, this is what I end up with. Okay. Now there's more we could do with this system, and we'll do it a little bit later. We get the basics, and what I have here is essentially an upper diagonal matrix, but we'll talk about that when we do this without the x's and y's. Okay. So now we know and I had a -1y, it should be a +1y, because -25 divided by -25 is +1. So we know that this gives us a value of y. Is part of our solution. Okay. Well, 0x plus 1y equals -1. Is just y equals -1. Okay. And that's part of our solution. So we plug y equals -1 into our first equation, which is the first recent equation. Okay. Glad to see it, Kat. Okay, y equals -1 goes into equation. Okay. Well, plugging y equals -1 into this equation, which I've repeated, gives us 12x minus 9 times -1 equals -3. The y is replaced by -1. giving us 12x plus 9 equals -3. Well, 12x plus 9 minus 9 equals -3 minus 9. 12x equals -12. We got x equals -1. I put 3 dots here because you do need the step where you divide both sides by 12. There we have it. Okay, we circle the y equals -1 because that's part of our solution. We circle the x equals -1 because that's part of our solution. Okay. Now we go back to the original equations, because these are the equations we have to satisfy. So what I'm going to ask you to do is replace x and y by -1 in the first equation and see if it works out. Okay. Then do the same thing in the second equation. Plug in x equals -1, y equals -1 into each of these equations and see if you get two identities. If so, then we have a solution to the system. Okay, now what we're going to do is kind of neat, I think. And it's really, really powerful. There are two branches of mathematics that underlie almost every field that uses mathematics. One is calculus, the other is linear algebra. Okay, and this is the beginning of linear algebra. We're just doing the very beginning, but I find that I've had classes of 8 or 9 linear algebra students. In order to get to doing this, half of them drop out. Okay, which that's something they should have learned in high school. Okay, but we do this little twist on it, and it confuses the heck out of them. So I'm trying to do this in a way that doesn't confuse people. So I'm doing it step by step. So we started with the system. To write this kind of small. 4x minus 3y equals -1. 3x plus 4y equals -7. Okay. Then I wrote this as 4x minus 3y equals -1. 3x plus 4y equals -7. In brackets, I call this 1, I call this 2. Right? Now, I said before, I refer to this equation as a row, not just as an equation, it's a row of this array. Okay? I refer to the second equation as a row. I refer to the x's, the x terms, which are all lined up in a column. And what am I going to call that? I'm going to call that a column. Okay? And the y's are lined up in a column, so I'm going to call this a column. First column, second column, and the third column is just the numbers on the other side of the equal sign. Okay? So I've got 2 rows and 3 columns. Okay? The next thing I do is I write this like so. I don't write the x's or the y's because I understand that this 4 is in front of x, so is this 3, right? And this -3 is in front of y, and so is this 4. And this little dotted line kind of indicates these are the numbers on the other side of the equal sign. So I can translate this to this, but I can translate this back to this anytime I want to. I just put x's on these, put y's on these, and I have to put a plus on the 4, or to make sure it doesn't look like multiplication, and put an equal sign here, and I have my equations back. That's very easy. Okay. So now this is what we call the matrix. With 2 rows and 3 columns. Okay. And I'll leave it at that for the moment. Now what I'm gonna do, I'm gonna take this matrix. And number the rows 1 and 2. And we're gonna do everything again that we did before. But I don't want you to look at what we did before. And if you got it on your paper, turn the page and write this down. Because I don't want you looking at any of this. Don't want everybody looking down there. Okay, now do this on your own. Without looking at anything else. Okay? So what I'm gonna do is the same steps I did before. Okay? So once you do that with the numbers in the matrix, when I do 3 times row 1, I multiply all these numbers by 3. If I do -4 times row 2, I do multiply all the numbers in row 2 by -4. And then I'm gonna write down whatever I got for row 1 here, that's what's gonna go here. Well, that's gonna be the same. And whatever I got for row 2 here, well, whatever I got up here for row 1 added to whatever I got up here for row 2 goes here. So let's see if you can do those 3 steps. Okay, now do a couple of steps here because most people have the first couple of steps down pretty well. Okay? Don't skip to what we were doing before with equations. There are no equations. Although you can always translate these 2 equations, we do not do so until we're done. Okay? So 3 times row 1, everybody knows that's 12, -9, -3. -4 times row 2 is -12, -16, 28. Everybody got that, I think. Okay, then what? Row 1. It says just write down row 1. Okay, in the previous step. That was easy. And then we do the row 1 plus row 2. Well, we have a 12 and a -12 in the first column. That adds up to 0. We have a -9 and a -16 in the second column, so that's going to give us -25 in the second column. And then we have -3 and 28, which gives us 25. Now, in the next step, we again write out row 1. You might be tired of writing out row 1, but we got to have it because this matrix has a meaning and we want everything to be there. Okay? We'll see as much of that meaning as we can. But right now, just going to follow steps by row. Okay? And then we do row 2 divided by -25. Then we'll talk about why we did these steps, and then we'll do a couple more. Okay. Up here. Second line, second row, divided by -25. 0 divided by -25, not surprisingly, is 0. -25 divided by -25 is 1. And 25 divided by -25 is -1. Okay. Now we can, at this stage, we can translate this into an equation. Y equals -1. And we could write out the first equation. And actually, we could use back substitution, as you'll probably see in your textbook, okay? Your online textbook. And get the solution of the whole system. It's pretty easy to get that solution, okay? Well, I'm going to take this another step just to see what can be done. But let's first look at why we did what we did. Okay. Notice we need to get a 0 here and a 1 here in order to get something that translates to a solution, right? Because this stands for no x, so forget it, and 1y equals -1, which means that y equals -1, and of course we know that's our solution for y. So we've got to get it. Okay. Now, it's a little cramped here, but I think I can get it somewhat legible. Okay, now I'm going to take equation 1. Now, okay. Okay, so let's just bring this equation up here, or this system. And the next thing I want to do is I want to do equation 1 plus 9 times equation 2. Equation 2 is done. I don't want to mess with it. It already gives me a solution for one of my variables. Okay, so go ahead and write down what you get if you do this operation. Yeah, well, did I? Okay, let's find out this. Some of you are close, some of you got it. So what do I mean by 1 times row 9 times 2? Okay, we don't want to multiply this row by 2. I never said multiply this row by 2. Nobody did. Okay, but you got to kind of do that, maybe in your head and maybe off to the side someplace. You don't want to do it within the column of the line matrices because it messes up your alignment. Okay, so watch this. Okay, row 1 is 12, -9, -3, right? And 9 times row 2 9 times row 2 is pretty easy to calculate. Row 2 is 0, 1, -1. 9 times that is 0, 9, -9. Now, we never want this row to appear in any of our matrices, but off to the side again, so we don't mess up beautiful alignment of our matrices. Okay, we write it out like this, and what do we get? Now we get 12. -9 and 9 is 0. -3 and -9 is -12, right? So row 1 plus 9 times row 2 is this. Now you can do that without writing it off to the side, baby. You don't lose track of what you're doing, but it doesn't hurt to write it off someplace in a piece of scrap papers. Okay? Or just off to the side where you got in the margin of your page. Okay? So line these up along the left side of your page and in the margin do any little calculations that you can do. Okay, so another way to see it though is look here. We're gonna do 12 plus 9 times 0, right? We're doing the number in row 1 plus 9 times the number in row 2 for each column. That gives us 12. Now, we're doing -9 plus 9 times 1. Well, 9 times 1 is 9, so we're doing -9 plus 9 gives us 0. And then we're doing -3 plus 9 times -1. 9 times -1 is -9. We got it here. And add that to -3, we get -12. Our second row, we don't change ever. Although we can use multiples of it. Okay. Now, the last thing we do is divide row 1 by 12 and then write out row 2. No 9 divided by 12, and don't use a slash. Slash, just easier to make mistakes. And if you really want to, it's okay to make mistakes. But you got to divide by 12. And I see what you did. You read the 1 in the 12 as a slash, but it's like a 1 division sign 12. Okay. So probably should have separated that a little better. Now, can you translate that back into an equation with X's and Y's for system equations? Okay, now this is really a simple step. People have misread some of the stuff and so forth, and not everybody got it right, but everybody seems to be on the right track now. Take every number in row 1 and divide by 12. That's all it says. That's what this says. So 12 divided by 12 is 1. 0 divided by 12 is 0. And 12 divided by -12 is negative. And then row 2 comes down just as it was. Now we translate this into a system of equations. What does this mean? Literally, first row would become x plus 0y equals -1. Second row here would become 0x plus y equals -1. Or x equals -1, y equals -1. And that's the solution to the system. You plug these numbers for x and y back into the original system of equations. And we've already done that, and we found that they give you identities. Okay? So we have found the solution. Now, I want you to follow the same system. But you'll have a good, I want to keep all this up here for you. Let's do other system I used earlier. Sorry, I'm not board. Another one probably against my knee. Okay, instead of this system, let's see what we can do with this system. Strategy is like this. Why did I multiply the first row by 3 and the second row by -4?
So you have
I
a
did that,
yes.
so I get a 0 here. Now you gotta pick different numbers for this system, okay? But you do that to get a 0 here. So what I say is, we match up the x terms. You know, this step makes the x terms equal and opposite, so we can add them and get 0. Okay? Then we want to get the second row in this form. Okay, no. Everybody's doing what they're doing, so I'm gonna let you do it. Then when I get your attention, look at this. Okay. Go ahead, it's what you're doing. Okay, now people did well. Okay, people seem to have the process down, seem to understand the conversion to matrix. We don't have time to complete all the details. But everybody appears to be on track. And that's cause for celebration. Okay, because this is the last thing we did in the course. Well, actually, there's one more. We do some applications, quadratic functions. Okay. But this is the assignment. Now, there's another assignment before. There are 2 assignments before. They're solving systems of 2 equations and 2 unknowns. They're solving systems of 3 equations and 3 unknowns. And then there's the thing on matrices. Okay. I think if people are in pretty good shape of solving 2 equations. We haven't addressed solving 3 equations because people have been having trouble or they're behind or whatever. Okay, so next time we'll talk a little bit about solving 3 equations and 3 unknowns, but you should already be somewhat adept at that. If you're not, go back and do the assignments. Okay. Excuse me. So that'll be our topic next time. We'll go to 3 unknowns, and then your matrix will have 3 rows and 4 columns. It gets a little more complicated what you do, but if you've got this down, I think you're going to understand, which is fine.